Hi, my name is Silvana. So me and my partnership kind of decided to do the poster, and we're going to be talking about the components and the role of components in our model example, which is the epinephrine pathway, as well as the different types of cellular responses elicited, and explain how a change in the structure of any signaling molecule affects the activity of the signaling pathway.
So starting off with our first step, which is reception. In this step, we have the ligand, which is epinephrine, and it's the triangle that we have here, so like in the top left. So the ligand here, it's going to bind to a GPCR, which stands for a G protein coupled receptor. And it's just a type of receptor, which is used in this pathway. And so when epinephrine binds to this GPCR, it activates the receptor and it causes it to change shape.
In transduction, the signal is relayed or amplified inside the cell, and it often involves secondary messengers like cyclic adenosine monophosphate or phosphorylation cascade. The components are the ligand being the epinephrine, GPCR on the cell membrane as a receptor, G protein and its components, alpha subunit, adenylate cyclase, and protein kinase A. The GPCR activates a G protein by causing the exchange of GDP for GPP. The activated alpha subunit of the G protein dissociates and moves along the membrane to bind to and activate the enzyme adenylyl cyclase, which catalyzes the conversion of ATP into cyclic adenosine monophosphate, a second messenger. Cyclic adenosine monophosphate then activates protein kinase A (pKa), triggering a phosphorylation cascade that amplifies the signal. An example of how a change in structure could affect the activity of the signaling pathway is if adenylyl cyclase active site changes shape. It can't convert ATP to cyclic adenosine monophosphate without cyclic adenosine monophosphate. Protein kinase A isn't activated and the signal can't be amplified.
Our third and final step is the response. So, as Silvana mentioned, protein kinase was activated by cyclic AMP in transduction. And so, now that protein kinase is activated, it's going to activate glycogen phosphorylase. And what glycogen phosphorylase is going to do is it's going to break the bonds of glycogen. So, if you can see, like in the bottom left, we kind of have modeled here the glycogen. So they're kind of like the hexagons that are together. And so we're going to have glycogen breakdown here, and this is going to help increase blood glucose levels so that the body can use it for rapid energy. Thank you for listening to our presentation. We hope you learned a lot about the signal transduction pathway, specifically with the epinephrine pathway. Thank you.